62. That's how many of these cats existed on the entire planet in 2001. Not 62 litters, not 62 sightings, 62 adult animals standing between the world's rarest wild cat and extinction. Today, official counts put that number above 2,000. By nearly every historical model biologists use to predict species recovery, that kind of jump should have taken 100 years, maybe more. It didn't. It took 20. Something in that math doesn't add up, and the deeper you look, the stranger it gets. Because this wasn't a slow, quiet comeback. Satellite records show the species didn't just survive. It exploded outward, claiming territory nearly 8 times larger than the small pockets it clung to only years earlier. Animals raised entirely in captivity, with no wild hunting experience, were released into open scrubland and expected to struggle. Almost none of them did. To understand how that's possible, you have to go back to what this landscape actually looked like before any of this started, fractured by roads, stripped of the prey these cats depended on, written off by more than one expert as a lost cause. Rescuing the predator meant rebuilding an entire food chain from the ground up, and almost everyone involved assumed it would take generations. It didn't just work. It worked fast enough to force one of the most conservative scientific bodies in the world to officially change this animal's extinction status. A reclassification that almost never happens this quickly, if it happens at all. But the population numbers and the map aren't even the most surprising part of this story. The real turning point came from an unexpected place, the very people who used to be this animal's biggest threat. What happened between them and this predator is what actually made the recovery permanent. If stories about measurable, real-world conservation wins are worth your time, hit like and subscribe. This channel is built entirely around verified data behind the biodiversity comebacks most people never hear about. To understand a recovery this fast, you have to see how far there was to fall. By the early 2000s, this landscape wasn't just empty, it was cut into pieces. Roads sliced straight through ancient hunting corridors, and for a predator that needs unbroken ground to survive, every highway became a wall. Territorial surveys from 2005 confirmed just how bad it had gotten. The entire population was boxed into a mapped range of only 449 square kilometers. That's it. That was the whole world left for the rarest cat on Earth. But the roads were only half the story. The other half was quieter and far more dangerous. The European rabbit, this predator's primary food source, was already listed as endangered, gutted by repeated viral outbreaks tearing through the population for decades. Almost no one was watching that collapse. While the world worried about the cat, its food supply was disappearing in silence. 2 crises unfolding at the same time, each one hiding the other. The predator wasn't just losing space, it was starving in the space it had left. Fixing that meant rebuilding an entire food chain from scratch, something many scientists at the time believed was already too late to attempt. If the food web was broken, the fix wasn't going to come from waiting. After 2010, teams across Spain and Portugal launched something closer to a logistical operation than a conservation program, moving more than 400 captive-bred individuals across borders into carefully mapped release zones. Transport logs, veterinary checkpoints, coordinated handoffs between countries. This wasn't a handful of animals. It was a supply chain built to rebuild a species. And here's where it should have gone wrong. Captive-bred predators almost never adapt cleanly to wild hunting. Zoologists expect losses, animals that can't read terrain, can't hunt live prey, can't survive first contact with the wild. That's not what happened here. Release after release, these cats adapted to hunting conditions with almost no transitional deaths. Numbers that broke the standard model for what captive carnivores can do. If stories like this matter to you, subscribe and join us as we uncover how animals continue to reshape the world around us. Because survival was never really the question here. As these animals stepped out of their transport crates, they didn't just survive, they began physically remapping the borders of the peninsula. Here's where the satellite data stops looking like conservation and starts looking like conquest. Back in 2005, the entire range was locked at 449 square kilometers, a handful of isolated pockets, cut off from each other. Today, GIS tracking puts that number above 3,320 square kilometers. Not a modest recovery, a seven-fold expansion in territory this species hadn't touched in generations. But the map alone doesn't explain how strange this expansion actually was. These animals didn't just spread into empty wilderness. They crossed some of the most heavily modified ground on the peninsula to get there. Farmland, highway corridors, developed edges most predators avoid entirely. And somehow, that's exactly how isolated populations, boxed in for decades, found each other again. Piece by piece, the fragments started connecting. What used to be scattered survivors clinging to the last patches of scrubland became something closer to a single, continuous population, stretching across land nobody expected them to cross. But reclaiming that ground meant walking straight back into the territory of the one species that had pushed them out in the first place. This geographic expansion immediately brought the wild predator face to face with its historical antagonist, the human community. Here's the part that should have stalled everything. A predator this size expanding into farmland and hunting grounds should have meant conflict, landowners protecting livestock, farmers protecting crops, hunters protecting game. That's the historical pattern. It's not what happened. Instead, the Life Links Connect project pulled these groups into the same room. Landowners, intensive farmers, gamekeepers, traditional hunters, factions with almost nothing in common, aligned around one shared goal: protecting the expansion instead of resisting it. Project coordinator Francisco Javier Salcido Ortiz has described the effort as built on sustained, cross-sector commitment, not a one-time agreement, but an ongoing coordination between groups who used to see each other as adversaries. And the biggest surprise wasn't that farmers tolerated the predator. It's that hunters and gamekeepers became its strongest defenders. They realized something the models hadn't accounted for: a healthy apex predator meant a healthier, more balanced game population underneath it. Protecting the lynx protected their own interests. Human conflict, the oldest obstacle in predator conservation, had been neutralized. And with territory expanding and resistance gone, the global scientific community was forced to issue a historic reclassification. Numbers and coalitions can only take a story so far. At some point, the science has to make it official. And it did. The IUCN, one of the most conservative bodies in global conservation, moved this species off the endangered list entirely, reclassifying it as vulnerable. That single word change represents decades of population growth, territorial expansion, and human cooperation, condensed into an institutional verdict. But the real insight isn't the status change itself. It's what the green status assessment reveals underneath it. That framework doesn't just measure how endangered a species is right now. It measures how much of its historical range and ecological function has actually been recovered. And by that metric, this population is still classified as largely depleted, nowhere near its full historical footprint. Here's the surprising part. Despite a century of habitat loss, enough intact land still exists that researchers project a realistic path to fully recovered status within the next 100 years, if current momentum holds. Not hope, a modeled, data-backed timeline. The South had proven the concept worked, and that success cleared the path for a much larger, unmapped expansion into the horizon. What happened in these scrublands was never really about one cat. It was proof of something conservation science has debated for decades: that an ecosystem written off as unsalvageable can, under the right conditions, rebuild itself faster than any model predicted. Because once you step back, the pattern becomes impossible to ignore. A predator reduced to double digits, a collapsed prey population no one was tracking, roads that fractured a landscape into disconnected islands. And then, one by one, each piece reversed. The prey stabilized. The fragments reconnected. The people who once saw this animal as a threat became the ones protecting it. A conservative scientific body changed its official assessment. None of that was inevitable. All of it was built. That's the real discovery here. Not that nature is resilient, but that resilience only becomes recovery when it's paired with precise, sustained coordination. Biology provided the capacity. Administration provided the outcome. And this is only the beginning. Central and northern Spain now sit inside active reintroduction planning, part of a broader push tied to global 2030 biodiversity targets. What worked in the south is being treated as a working blueprint, not a lucky exception. So here's the question worth sitting with. How many other landscapes, written off the same way this one was, are still capable of this kind of recovery, if someone simply decided to try? If stories like this matter to you, subscribe and join us as we uncover how animals continue to reshape the world around us. The next investigation takes us far from these dry hillsides, into a wetland corridor where a single bird's return quietly altered the water itself. See you there. Survival, in the end, was never the hard part. Coordination was.